Good morning and good afternoon, everyone. Thank you for joining our webinar, Data for Breakfast, the online version. So here's the agenda. We'll do brief introductions. Then we'll dive right into the Snowflake presentation, which is centered around enabling your organization to be data-driven. We'll then listen to the Hover presentation. And finally, we'll wrap up with Q&A. We will have live Q&A at the end, so please chat us your questions in your console. As always, the slide deck and recording will be made available upon completion of the session. Okay, so introductions. My name is Jeannie Liu. I'm a product marketing manager here at Snowflake. I focus on core product marketing and was heavily involved in the Data for Breakfast physical tours. I'm joined by Jay Rosenthal, Director of Data at Hover, where he owns data infrastructure and manages analysts and data scientists. His specialty is bridging business needs with engineering teams. He was our speaker at the Palo Alto Breakfast, so we're excited to have him online today. Welcome, Jay. As a recap, for those who weren't able to attend, Data for Breakfast is a series of tours all around North America, from Toronto to Miami, from Palo Alto to New York. We hosted a series of breakfasts for customers and prospects to enable you guys to learn how to get your organizations to be data-driven. As you can see, they were well received, and we're excited to have you part of this experience through the online version today. So let's get started about how to enable your organization to be data-driven. Speaking with several leaders in the industry, customers and partners, we saw some common themes that really prevented organizations in becoming fully data-driven enterprises. Maybe some of these points are common to you. The first is siloed, diverse data. So you have many data sources and stores. Scale and speed issues, where you really can't scale up and out easily. You have complex, costly architecture that leads to complex, costly infrastructure. You have hardware costs and software costs. And finally, you have slow, limited decision-making. I'll get into the details of each element in subsequent slides, but this was really the framework that we used to understand the problems that customers, prospects, and the industry was facing. So let's get into siloed diverse data. Today you have data that comes in from a variety of sources, including the web, mobile devices, apps, and it's generated from a variety of systems such as transactional databases and ERP systems. It's then typically stored in a variety of databases, or you could have it in data warehouses, data marts, and even data lakes. As you know, you experience some of the data is semi-structured, some of it is structured, and what this leads to is siloed diverse data. And this is an issue because the BI teams can't quickly run analytics or correlations on this data. And what we've found is that conventional data warehouse solutions weren't really designed to handle this volume, variety, and complexity of today's data. And even if there were new systems that were designed, there are still shortcomings with data access and analysis that's required today by organizations. So let's go to the second topic, which was scale and speed issues. Current data warehouses may be on-prem or be built on rigid architecture, and it's really difficult or costly to scale up or out to accommodate additional streams of data, run queries, and even advanced queries, and support concurrent users. So what you get are slow queries, and oftentimes the ingestion of data is limited. More importantly, there's resource contention. So you have different workloads, such as ETL jobs, and they often impact one another adversely, and this leads to limits being placed on different groups. Now let's get into complex, costly infrastructure. So you have a lot of the associated data stores that actually experience this as well. You have to pay for additional software licenses and hardware costs. More importantly, you have to over-provision your warehouse to handle spikes in workloads. So you're basically paying for resources that sit idle most of the time. Added to that, you have significant maintenance and tuning costs. You have a lot of manual work and overall DB involvement to handle distribution keys, partitioning, and vacuuming. So just a lot of overhead costs that you may not necessarily need. And finally, we get into slow, limited decision-making. So the question I have to the audience is, what sort of software, hardware, and maintenance costs do you incur for your data warehouse today? And really, let's think about how many resources and work and how much work is needed to maintain that infrastructure. With all this maintenance, you have limited decision-making. You also have limited queries, and you oftentimes have to restrict user access to the system so it doesn't bog down the entire system. What this leads to is stale data and incomplete data because it can't be loaded all together into the same data warehouse in a timely manner. And it's also siloed and put into different data stores. So you have disparate, disjointed data, and you can't run proper analytics and correlations that you need to increase revenue and reduce costs for your organization. So what do we do? So our mission at Snowflake is to enable organizations to become data-driven. We want to give you the ability to harness all of your business data to make better, faster business decisions, and we want to make this data available to any number of users. You know, it actually really sounds like a simple goal, but a lot of companies struggle with it, often because they're working with outdated infrastructure. So briefly, our story, Snowflake is a SQL data warehouse built from the ground up to leverage the capabilities of the cloud. And this is an important distinction because it gives us permission of another framework, and that framework being a cloud data warehouse. Why is this important? It's important because with the cloud, you have access to near infinite low-cost storage. You have improved scalability. You have the outsourcing of data warehousing management and security to the cloud vendor. And you have the opportunity to pay for only the storage and computing resources that you actually use. So let's take a look more specifically at the Snowflake solution. Cloud data warehousing, or Snowflake in general, is a cost-effective way for companies to basically take advantage of the latest technology and architecture without the huge upfront cost to purchase, install, configure required hardware, software, infrastructure. The important thing here is that with Snowflake, all of your data is centralized and also shareable with external parties. Snowflake can store both structured and unstructured, so JSON, XML, Avro data. What that means is that all of the data can be consolidated into a single repository in the cloud as basically a single source of truth. And this is where the analytics can come in and be run across all of this data. So you don't have any more scattered, siloed data. And another point to note is you have live data, and that can be easily shared and securely shared with external partners with in Snowflake, even if they don't own Snowflake. So the data doesn't need to be moved or copied. And our success is driven first and foremost by our customers, and you will have the opportunity to hear from Jay shortly. But it's also driven largely by our expanding ecosystem of partners, including platform, BI analytics, and ETL partners. I'm going to wrap up my portion with this slide here showing that we have over 1,500 customers actively and successfully using Snowflake today. As you can see, our solution is vertically agnostic, where customers come from all industries and global regions, varying from data-driven startups born in the cloud to large Fortune 500 companies. And the common theme here is that Snowflake has drastically improved all of our customers' ability to enable users to access more data, run faster analytics, and ultimately make better business decisions. I know you all on the line are eagerly waiting to hear about Hover's use of Snowflake. So without further ado, Jay, off to you.
Thanks so much, and thank you very much for having me here today. So I'm Jay. I'm the Director of Data at Hover, and I lead an internal data team that manages our infrastructure behind analytics and reporting, and also, I lead the team that does it of data engineers, data scientists, and data analysts. And today I want to, start off with talking about why we picked Snowflake, and then dive into how Hover is using one particular feature called data sharing, which has really been a game changer for our business. But first, just to make sure you all know who Hover is we've got a really unique technology where we take photos from any home and translate that into an interactive 3D model, and we sell to contractors primarily, so they can save time and win more business by using our tool. So you get really detailed measurements, which are amazing. I'll show you the detail a little more granularly in 1 second. And then you also get an interactive 3D model where you can, show a homeowner what their house might look like instead of gray, make it blue like this screenshot. So let me just share my screen here. And I'm going to do a quick product demo here. So here you can see, one of our demo houses, and you can see these pictures that we took, 4 sides and 4 corners of the home. Go a little slower in case there's a lag. And then here we have really detailed measurements that you get with our product. So I'm going to come down here, and you can see here the areas, the openings, the siding, the trim, the roof line. And this is all done with computer vision and machine learning. And here you see it. This is really a data-driven product and a data product. Our customers are consuming this data. And then let me just scroll down, and here you can see, those exact measurements in every nook and cranny, what the measurements are. Then you can also go to our 3D model, and we've got design features. And here I'm going to take this house, and I'm going to take the horizontal siding, and I'm going to change it to, let's go James Hardy, lap select cedar mill in pink. There you go. You can change your house from gray to pink and see if you really like it, or maybe you prefer the cool breeze, the beach look. Cool. So that is Hover's product. And let me just also add, we're backed by top investors, including Google Ventures and Home Depot, great venture investors and great strategic investors. And then we're also hiring, like everyone else out here in San Francisco. We're hiring for data roles, and we're hiring for engineering and computer vision and sales. So there's my email. If you're looking for a new job, send me a note. So now that you know Hover, that's the context for how we use data. And really it's these 3 buckets. We've got internal reporting and analytics like any business has. Finance needs the revenue numbers, and sales needs to be able to, see how they're tracking against quota. And we have intense product analytics knowing, when you click that 3D model, what products are you visualizing on that 3D model? Then we have external reporting and analytics. Our customers are a massive range of people, everyone from, a guy and a ladder and his 2 friends that replace the roof to large national contractors that are, huge businesses. And they have different reporting needs. The big people, really want a reporting API so they can build their own reports and take our data and put it in their own data warehouse. And so that's where we use data sharing. And then we have our computer vision and machine learning team. And those engineers are building the product and what you see, and they need data from our data warehouse and good data systems to help, train their algorithms and make the things that build that 3D model, better. Cool. So, that sets up the context for what did we put in place. So before Snowflake, we already had a cloud data warehouse, but it really wasn't scaling with our business. The problems we were having were storage problems. Our database would fill up, and then queries would crash. That technology needed to keep a temporary buffer, so when queries ran, it could create like temp tables on the fly. So then queries crash, data gets behind, people are unhappy. So I changed the configuration from something for speed to something optimized for storage, and suddenly that caused data load latency. And then, people are unhappy for a different reason. Now their queries are succeeding, but they're just taking time, and their data went from being 2-3 minutes behind real time to being 45 minutes behind real time. And we had some business situations where that was just unacceptable. And then, it was too much management overhead. Now I was, fighting this instead of relaxing on the weekend with my wife and baking bread. I'm like, up at 8 a.m. on Saturday trying to configure my data warehouse. And that is, absolutely no fun, as everyone can attest to. So last, the solution we came up with and what we were trying to do was really to migrate to Snowflake without changing any other tools and without disrupting BI users. So here's what we put in place. This is our current architecture, and if you want to imagine what it was like before Snowflake, all you have to do is change this data warehouse out to someone else. When we put this in place, I was very adamant that we wouldn't have vendor lock-in, and we can change our ETL tool or we can change our BI tool, and we changed our data warehouse without having to sort of change everything. So to walk you through from left to right, what we have, in the lower left, you see application read replicas. We have many different applications, for different services that run our business. And we use this tool, Illuma, in the blue and green, to copy that data into our data warehouse in near real time. We also have a lot of cloud SaaS tools, which you see to the left of the Illuma logo. Things like Salesforce, our CRM, Mixpanel for product analytics, and a host of other cloud tools. And we want that data in our data warehouse so we can, blend it with our internal database data and do more robust analytics. We also use Segment for some different data integration. It can do cloud-to-cloud integration, and it also can put data into Snowflake. So, the nice thing about Illuma is you can write Python to transform your data in any way you want. And we love being able to do some of those transformations in real code upstream of the data warehouse. On the other hand, Segment can grab some different sources, and it's just quicker and easier, and it's just copying a table and replicating it, and that loads it into Snowflake. So it's great to be able to have, a good universe of tools that work with Snowflake. So again, we're not stuck with one tool for one thing, and we can use the best thing for any job. And then over there on the right, you see all the things reading from Snowflake and interacting with it. You see, S3 and Amazon SageMaker. Those are used so our computer vision and machine learning teams can train their algorithms. And you see Tableau over here with the chart and the tree map. And that's our main business intelligence tool. And then you see, people below that who are using custom code or writing SQL and querying the data warehouse directly. So, what we love about Snowflake is we've been able to solve a lot of those problems. So separation of loads and query, that took care of our speed and latency problems. We've got some resources loading data and a separate set of resources reading data. And I'm able to break that out and say, people get a different resource pool than Tableau, which is caching data hourly and querying almost all day long. We have simplified management. It's really easy to pull out those resources. I don't have to worry about how, lots and lots of tables and lots of data is going to affect my query performance with the unlimited storage. We successfully migrated without changing other infrastructure. For anyone who uses Tableau, there are a lot of tricks you can do by opening up those Tableau files in a text editor, and you can actually change out the database behind the scenes. So you don't, you can do that at scale. You don't have to do replacing references and all those tools in the UI that can be clunky. And if you're going to migrate, that'll make it much easier. Feel free to email me or ask questions about that. And then we have new capabilities like data sharing. And data sharing's, what I'm going to talk about for the rest of the time. So first, for anyone new to Snowflake, what is data sharing here? Data sharing is really, actually, let me stop there. For us internally, we're effectively data sharing with ourselves. So you've got your data stored, and in that context, you're a provider, as you see up in the top of this chart. And then internally, all those things you saw on those last slide are different consumers. We've got SageMaker as a consumer, Tableau as a consumer, various people are consumers. So, it was a byproduct of just the way Snowflake had built itself that you can use data sharing. Because now we're able to say, instead of, Hover's provider and also the consumer, we can say Hover is the provider and our large partners and customers are consumers. And they effectively, they get a subset of data, the things we make available to them with permissions, and they can query our data using SQL. So, data sharing is a common problem. Here's what we were doing before Snowflake, pretty simple. We had Tableau. Customer support was downloading CSVs. We were using, our email, Gmail, to send that stuff to the customer, and it was a chore. And you can imagine customers always want different things, and they want it, they want it every day. And it blows my mind, 95% of those customers probably aren't looking at the email report you send every morning, but they sure want to be able to look at it every morning. So that's a lot of work and a lot of overhead and really expensive. People are the most expensive thing in our business. So here was the business proposition for data sharing. First was automation. Get those people out of it and have a SQL-based reporting API. We really like SQL because it's a great language to interact with, and it makes lots of things easier than, if you had a traditional REST API that you need an engineer to code against. We want scalable and simple row-level security. So, security is paramount. You don't want to show customer A, customer B's data, and it needed to be simple to manage, but we wanted to be able to, build it once and let different customers see it. Then we want speed, especially speed to market. So we wanted to use our data team resources, which are people who know Python and SQL and Tableau and know our data like the back of their hand. But we didn't want to have to use our back-end developers building our application or God forbid, our computer vision engineers, take them off that work to have them build an API. So we were really able to get to market faster by having our team do it. We didn't have to compete with resources elsewhere in the company. And then we want fast experimentation. We rolled out with 3 tables with really core metrics, but there's a whole litany of other things we might want to do in the future. And the same thing that made it fast for us to spin it up will make it fast for us to experiment with new data sets down the road. And then lastly, we wanted to be customer friendly. So the SQL API is really customer friendly. There's tons of options for customers to connect. The same way, we can use lots of tools around Snowflake internally, our customers can use their tools. So, they can connect with Tableau, they can connect with Talend. So we have a customer connecting with Talend and pulling data nightly into their data warehouse. And it was a piece of cake for them to set up. And then we want a business team or data team or engineers to all be able to connect. So, we have a financial analyst somewhere else, and they can just connect Tableau right up. And so that's where you don't need your customer now dependent on their data team to code against our API. So you're just changing the dynamic by have it be a SQL-based API. Okay, so then setup and management. Here's how it went. It was easy setup and configuration via SQL statements. Anyone who's managed Postgres or MySQL will be familiar with those kinds of permission statements. We wanted to manage programmatically via Python because we want code review on things and really make sure that the permissions are good. We also want the automation that we can get by defining a new customer, a consumer who should get that data in just a little bit of a dictionary, a JSON dictionary, and then being able to run Python and go through everything and apply permissions or remove permissions. We wanted testing, so that's another thing that Python gave us. We have a lot of tests that make sure we're secure with the data we share and people are getting the right thing in that share. And then lastly, we have monitoring just via Tableau, and that's monitoring continuously. So let me dive a little into the details of the technology. So here's the getting started. We're using secure views. Secure views are a special type of view that doesn't show certain metadata about the table, and you create that with a very basic SQL statement. Another thing we really like about using views is, as fast as that data gets loaded into the data warehouse, the customer has it. So in the slide with architecture, you saw Illuma. Illuma's loading data into Snowflake every 2-3 minutes. It's updating things, so very near real time. And by using a view, we don't have a dependency stack where one thing can crash and data's out of date. There's no materializing data as we go down that pipeline. So views are really nice. Our customer gets that data in very near real time. Then permissioning. Permissioning is a piece of cake too. Again, it's very SQL-based. It's all SQL-based. So you're going to create a share. You're going to grant some permissions on the database, on the schema, on the view, and that sets up what the consumer can see. And then we're doing things with managed accounts. So there's two ways to do data sharing. One is where your customer has their own sharing account, their own Snowflake account, and they pay Snowflake directly. And Snowflake even has a rebate program, so you can recoup some of that cost. You can make money off that. So that's one way you could use data sharing to be a product feature and actually make money. For us right now, we're sharing this with large business partners, and really our costs on this are very minimal, just a couple $100 a year right now. So it didn't feel like being a good business partner to charge someone when you've got a big business relationship. And like I said, we're saving money by not having people on it. We're going to do this. We have to do this. So it's a cost savings to use Snowflake here. And so we're creating a managed account. So we create the account, we send those customers usernames and passwords, but we're going to see that cost on our Snowflake bill at the end of the month. And then, I mentioned the rebate. You could actually, if you want to manage their accounts, but then, have basically charge them for it, you could make a lot more money off it. So you could pay $2 an hour at list price and charge customers $5 an hour, so to speak, for reporting API for premium access. That's not something we're doing, but you could definitely do that and let your data team bring in some revenue instead of being a cost for once. So then the other side of this is really having good security testing on this. And we have unit tests, so using Python. And this is tests we run before we even deploy. So you'll see here some of the security conditions where it says ending security string, never comment out this code. This test makes sure that condition is in our SQL. And that's what sets the security. So account A sees account A's data and account B sees account B's data. And we run this before we make any changes to our views on the data warehouse. If this test fails, those changes will never be deployed. Then we have query tests. And this is right after that deploy. We run these tests to make sure we didn't mess anything up post-deploy. So you'll see down about 2/3 of the way down the screen, it says select account name, customer ID from MyDB shared schema customer account mapping. That's a mapping table between your internal ID for that customer and the Snowflake data share. And you can see a little farther down, there's customer mapping. For those of you who read Python, that's just a data frame. And for those of you who write SQL, imagine that in 3 rows of a spreadsheet, and you see a customer ID and account name. Sorry, two rows of a spreadsheet. So that test will run, and we'll literally query the database and make sure that we get back the right data that we expect after we deploy. And then lastly, we've got monitoring on. So we have Tableau, some reports set up with 3 kinds of monitoring. and this, we're having this run hourly. You could have it run daily or whatever you want in Tableau. But we've got three kinds here. The first thing that every job has a user, every job has an org. Those are making sure that when customers join the tables we made available, because we made 3 tables available to them, we didn't flatten our data there, that those joins maintain their integrity. Then we've got quality. We've got some complex SQL behind this to clean data and make that data easy for customers to understand. So the quality queries are making sure that we have the right number of unique records in that table, and a join didn't end up with 2 rows when we should have 1. And then lastly, we've got security. Again, just another check for continuous monitoring to make sure partner A sees partner A's data and partner B sees partner B's data, and vice versa. And then we've also got rate limiting. I mentioned we were absorbing the cost for this because it's a service we need to provide our largest business partners with reporting, and we can set up a rate limit. So right now, a lot of our partners are querying once a day to pull data into their own data warehouse. Maybe they're going to go to every hour, and suddenly they go to every 30 minutes. We have this rate limiting on it, so they won't be able to rack up a bill without us knowing. They'll hit the top of this quota, we'll get an alert, and we'll figure out where to go and whether we should increase it or not. So that's really the story of data sharing. Now our data goes right to our customer. Our customers using this love it, and our internal team loves it because they can now do the customer relationship management and not the emailing spreadsheets back and forth. So it's really been a great success for the data team. And so here are my closing thoughts. After 5 months of using Snowflake, we migrated in November. We really love the easy management. It's been really, really hands-free. So, no more Saturday morning trying to optimize storage space in your data warehouse. Isolating workloads is really the key for that. Separating, compute from load, separating different workloads. Like I just separated out human querying from Tableau querying because at first those weren't competing, but then there were too many queries, so now we had to separate them out. We didn't buy Snowflake's auto scaling. We decided to manage things by having dedicated resources for dedicated things instead of having one set of resources that auto scales, but both would be an option. And then lastly, data sharing lets the analytics team provide direct customer value and really, be more than just a cost, be more than a team that people shout at when they need data, and really be delivering things of value. So that's our Snowflake that's our Snowflake story and our Snowflake sharing story for that matter. And I'll pass it back to Jeannie for any questions.
Jay, that was excellent. Thank you for sharing your data sharing story. We do have a handful of questions specifically for you as well as for me, so let's divide and conquer. Great to hear that data goes right to customers. The internal team loves that. They can focus on customer relationship management. The question I have here is generally on your Snowflake costs. So can you comment on that? And just specifically compared to other tools in your architecture, how does it compare?
Yeah, I mean, I don't know that I should say my costs, but we are, we're a fast-growing business, and we bought the lowest level. So we were able to sort of say Snowflake's basic rate, and it was, when you think about the human cost and the opportunity cost of me spending, even in, an hour a week, let alone when you're spending, a day a week, we're paying more for Snowflake than we paid for our previous solution, but not when you consider that we're buying more. Our business has tripled in many metrics, including people querying, since we bought the previous technology. So we feel like we're getting a lot more for our money, and we're saving money overall by not, wasting time, managing data warehouses. Like that's not core to our business. People want insight from the data team, not us spending all day making our query run.
Absolutely. And how much data volume did you migrate, and what was the time it took you?
We've got about 2 terabytes of business data right now in our Snowflake cluster. So, that's not big data when you get out here. If you talk to the big data people like the game companies and Facebook and Google, right? We have baby food data from that standpoint. But we had complexity of a lot of sources. It took the total migration to Snowflake took about 2-3 weeks, where most of the complexity was around cleaning up our Python code and that ETL tool. We copied a lot of data rather than going from our previous data warehouse to Snowflake. We went right back to our databases and our cloud sources, and we took that opportunity to refactor lots of code and lots of structure within the data warehouse. And then, the Tableau piece and figuring that out that's what took the time. But it was relatively simple migration. We love Illuma because we get to write Python, but there are other tools like, Fivetran's another one. And if you were just plugging in Fivetran and changing things out, you would be able to migrate in a day.
Great. I got one question here, and I'll take it, somewhat similar. So the question is, can we use AWS Glue to load data from S3 to Snowflake? And the answer is yes. So for everybody on the line, with AWS Glue and Snowflake, basically customers get the added benefit of Snowflake's query pushdown, which automatically pushes Spark workloads that are translated into SQL into Snowflake. The two solutions enable customers to manage their data ingestion and transformation pipelines with more ease. There are 3 prerequisites. The first is the latest Snowflake Spark connector. The second is the Snowflake JDBC driver. And finally, the S3 bucket must be in the same region as AWS Glue. Okay, Jay, for you. Jay, love your security and data QA. Are there any testing or quality checks that you'd recommend or plan to add in the future?
We could clean up our Python, right? There's things where we have 3 tests, and we could probably write it more elegantly and have 1. So that's definitely in the roadmap, because as we have more customers and more data and more tests, that'll all get more complex. There aren't any things off the top of my head about things to add, but one thing in reviewing with our security people was do everything. So there were some things in there that that I didn't show off. So, for example, we have just a few partners sharing data right now, and we hard code their IDs into that query. So again, you're at risk of sharing with A and B, but there's a whole host of people that you'll never be at risk with. So I would say for security, literally every test or check or balance you can think of, just put them all in there, because the chance of one thing failure is probably pretty high. The chance of 5 things failing is a lot lower. And you want to make sure you don't have any single point that will make you expose your data to people who shouldn't have it.
Absolutely. And maybe this is a follow-on to that. So what was the challenge that became the catalyst or catalysts to leave your previous solution?
Yeah, the challenge was really about the trade-off between query speed and data volume. So in our previous solution, you can choose, like a configuration that runs fast or a configuration that holds a lot of data. So we started off on the configuration that was fast, and then our data became too big. And then we went to the configuration that holds a lot of data, and suddenly queries were slow. So it was like you fix one thing and you break another. And the question on cost before, another way to answer it is, we could have stayed on our old technology and paid 4 times as much, but we basically migrated to Snowflake and paid twice as much. So, even from a hard cost perspective, if we wanted the same performance, that we had when we started the old technology, we had to pay a lot more. You're like paying our starting costs and hoping for our starting performance when our data had grown 4x in a year. So, Snowflake was a cost savings overall. And then, that pain of being able to, separate out your workloads and not have your query performance and your load speed are managed totally separately. So, and your data storage size. So you can manage all those things and optimize for what you need. So like, for example, you could have lots of data retention in Snowflake and you're going to pay a lot for your storage. Or you could, say, I just need a little data retention or they're fail safe and not pay a lot for storage. And those decisions are just made without even thinking about your query speed. So it's nice to be able to think of those things independently and optimize individually.
That's such a great point, Jay. And I'm going to take this question, which is, what is the services layer? What does it actually do in Snowflake? So I think let's think about the cloud service layer as what makes Snowflake a service. So if the virtual warehouses you spin up are the brawn of the system, we can think of the cloud services layer as the brain. So it can run in EC2 and Azure Blob Storage. It's always running whether you turn all of your virtual warehouses on or not. It's basically where all the metadata layer resides, where the query optimizer resides, and where access is controlled. It's totally transparent from the user. And finally, it manages transactional consistency. Jay, this is a follow-up to your previous question, which was, give us the names of the technologies used in your previous solution.
Yeah, we were using Redshift before. So the trade-off was, really between compute nodes and storage nodes. And, when we first checked that out, it was a lot cheaper. And the sticker price is nicer, that you start looking and you say the increments of cost to scale up are less. We have, we needed an always-on 24/7 data warehouse. So, we had a base capacity. And if you're looking at sticker price, at first Snowflake seemed more expensive for base capacity, and that's why we went with Redshift a year ago. But I totally regret it. I mean, it was fun to learn Redshift, but from a total cost of ownership perspective, it was the wrong choice. I would have saved money certainly on my time if I hadn't been doing all those things to manage the cluster.
That's good to hear, straight from a customer's mouth. This question is also for you. What does your data pipeline look like? Raw data, staging data? Do you have truth tables, data marts reporting? Are these organized with schema?
Yeah, we pretty much have. So our data, we're getting data from a lot of sources. So if you imagine cloud sources and databases. And then we have different tools to load it. So you can load stuff with our tools like we're doing with Illuma and Segment. You can also load data from Snowpipe, which is a Snowflake data loading feature, or you can manually load data, via copy commands from S3. So the way we've organized it is we have a different database in Snowflake for each tool that's loading data. And for those of you who aren't coming from if you're coming from a Postgres world, you're going to be used to, schemas and then tables that you can query across. In Snowflake, you can query across databases. It's just you say, database name, schema name, table name. So what we've done is we've said databases are separated by the things that load the data. And then we have schemas that are named by the source of that data. So, if you imagine Salesforce, Salesforce has a schema in the Illuma DB because we use Illuma to load that. And if you imagine, some internal application that we're loading through Illuma, that has the name of, the Illuma DB internal application schema, and then all the tables in there. So that's how we're organizing it. And then the types of data we're getting, certainly our databases have a lot of JSON. And we have, and then clean tables. We get webhooks, which are all JSON. we do a lot of work in Illuma to flatten JSON and denest it. And we like that because, while Snowflake's, variant data type and querying into JSON is awesome, like you've got to really know that data to be able to even find something in nested JSON. So from a data discovery perspective, it's nice to flatten everything in columns because it's really easy for someone to read and see what's available in that column structure. So hopefully that answers your question about organization and data pipeline, and yeah.
Excellent. As a follow-up, I can take this one. So this one is, how can I load data into Snowflake? So you could use multiple methods. In all cases, there's no transformations required. So in the event that you have semi-structured data or tables or pre-schemas that you don't need, there's no transformations required. So the first method is you could use your ETL tool of choice. So that could be Talend or Informatica. And you basically just point to Snowflake just like any other database. The other way to do it is to connect to your cloud application. So we have people using Salesforce or Marketo, and then they use an ELT partner like Fivetran or Matillion to extract and export and load. You could also use the copy command in the Snowflake UI from the Snowflake S3 bucket. You could use a CLI, you could use a script, Python, JavaScript, or you could use a client-based application or Snowflake's tool via a JDBC or ODBC connector. Okay, this question is for you, Jay. Did you change your ETL tool for the data warehouse?
No, we picked Illuma, and then we had Illuma spin up a second instance, and we were able to then use Illuma to migrate data into Snowflake. There was a question about how long it took. Our old Illuma was on Python 2, and then their new instance was on Python 3. And that's really where the time spent migrating was. It was like, converting things to Python 3 and refactoring code here and there on the ETL tool side. The Snowflake side was super easy.
Excellent. Now this question comes in about concurrency. So how did you deal with concurrency? Did you do a multi-cluster configuration, and how did you manage spikes?
So we didn't buy the auto scaling. So what we're doing is we're able to deal with concurrency by separating workloads. So Snowflake, everything has a virtual warehouse. So what we have right now is we have one virtual warehouse for Illuma to load. We have another virtual warehouse for Segment to load and both of those auto suspend after 1 minute. So it'll spin up, load data, spin down. Illuma's running, probably half the day on and off constantly. Segment just runs a little bit because it's more of a batch tool. And those are using dedicated resources to load that data. So they're not competing with other things. And then again, on the read side, we have a separate warehouse for people to query, then Tableau to run its hourly batch caching. We make a lot of use of Tableau. And that's actually one way we absorb concurrency is, there's a few things that need to be near real-time reporting, but 90% of stuff doesn't. And all those analytics, like how is the business doing year over year? How, what are accounts performing like this quarter? Like you don't need the last hour of data. So we're having Tableau run extracts hourly, and we're able to sort of flatten data sources and provide self-service data sources in Tableau by doing that. And that, puts a lot of the dashboard load is coming into Tableau's cache and not even on Snowflake. So again, we're able to manage that concurrency by separating out all these resources in their use of Tableau. The other way would be to pay for auto scaling, which puts you at a more expensive price point starting Snowflake. But depending on your use case, if you're using Looker, which is live querying a lot more, you might very well want that.
Absolutely. And for the audience on the line, so basically there's two different modes. Maximized is when the warehouse is started. Snowflake always starts all the clusters to ensure maximum resources are available while the warehouse is running. And as Jay mentioned, there's auto scaling, which basically Snowflake stops and starts clusters as needed to dynamically manage the workload on the warehouse. Okay, Jay, for you as well, how are you monitoring database loads, and do you have to manage different types of workloads? How do you manage that?
It's all done through the ETL tools. One cool thing about Snowflake is they do make some system tables available. So you could create your own, SQL reporting and monitoring and alerting around that. We haven't had to do that yet, so we haven't bothered to do that yet. So monitoring is really pretty much done in the ETL tools. Those are throwing alerts when things fail on load, and we're resolving things there.
Great. And you may have already answered this question, but do you use some sort of schema tool for your unstructured JSON data with Avro, et cetera?
We don't use a schema tool for that. Illuma will do a lot of the schema things, like if a new column is added to a table in your production database in the read replica, Illuma is going to recognize that new column and bring it in and map the data types and add that column. And you can configure Illuma, our ETL tool, to say, wait a minute, just do it automatically and don't tell me about it. Like, I love you, take care of it. Or you can say, I don't trust you, Illuma. I want to make sure you did what I want. So we're using those tools to deal with schemas. We have a lot of JSON. For the most part, we'll DNest JSON 1, 2, maybe 3 levels deep, and nested JSON that goes deeper, we'll let go into variant column in Snowflake. Variant is their JSON data type. And then we're not using other semi-structured data types at this time.
Great. We're about 5 minutes to the top of the hour. I do want to end on this question, and we can have follow-up questions. So basically, has the consumption-based nature of Snowflake changed the way that Hover thinks about deploying projects and measuring ROI of projects? And I think this is important because now you have a really clear path of understanding your costs. You can control what you use, when you use it, and how you use it as you pay for what you use.
Yeah, I'm sorry. Could you repeat the takeaway of that question one more time?
Sure. So has the consumption-based nature of Snowflake changed the way you think about projects and measuring the ROI of projects overall for Hover?
Got it. Yeah, I mean, we're still a startup, so we don't have, like a Google where you're really worried about your costs. We're just at a smaller scale. So, it doesn't really influence us. We have business needs, and we're willing to pay for those needs. And I wouldn't say Snowflake's changed how we think about those costs, but they've let us control it. Like with the other technology, with Redshift, we were basically at a point where we would have had to go to 4x the cost just to get the same performance. And we wouldn't have had any levers to control it in the future. Now what we like is because we can separate those resources out, we could do things like activities-based costing and say this thing gets this much cost and this other thing gets that much cost. If you wanted, if you're a team serving a huge number of people, those virtual warehouses would actually be great for activities-based costing because you could give everyone their own independent pool of resources, right? And that's not even about concurrency. That's about passing through someone's exact usage to them without doing hard math to calculate that. So I think it would let you control costs better as you grow. We think it'll help us with that, but it wasn't really a near-term driver.
Got it. Understood. Okay, well, we're going to wrap up. There's still a handful of questions coming in, and we'll definitely get to those offline with you. As I mentioned before, Data for Breakfast was a really successful series of events for us. We visited 29 cities over the course of 1 month in the month of March, and we're going to be having these again next year, so we hope to see you at one of these physical locations. We'll also be doing the online version. And in these Data for Breakfast events, we have a Snowflake presenter, followed by a partner presentation, and then we highlight it with a customer presentation. So it's a chance for you to not only hear from speakers, but mingle with like-minded individuals. I hope this webinar was informative for everyone on the line, and I want to thank you, Jay, again for all of your contributions, and we'll follow up with the slide deck and recording. Thank you again, and everyone have a great day.